So thanks again, for having me this afternoon. And some of you may have already, seen me during the panel discussion just before lunch or before breakfast for you, David. So I will talk about intelligent maintenance in food and feed processing, and actually, I should have also said and advanced materials as well. I'll also show you one example from there. So I'm from a company called Bühler, and even if you don't know Bühler, it's quite likely you have actually come into contact with Bühler products, so products that have been manufactured by Bühler customers. So we are a solution provider for the food industry and for the advanced materials industry. And on this slide, which takes you through a typical Bühler day, you just see a couple of examples. So breakfast cereals, for example, are extruded on Bühler extruders. Pigments for cosmetics or lipstick here, so this is ground on Bühler mills. Pet food is extruded again, or also dried on Aeroglide dryers. We have coffee, so we have roasters for coffee. But next to the coffee, you would also see biscuits. That's also made on Bühler equipment. But also then mobile phones. So, for example, the coatings on lenses. This is made on Bühler labeled equipment. Also for sunglasses, the coating there. So you already see quite diverse markets that we're in. Pasta, so 40% of the world's pasta is made on Bühler equipment. Rice, we're #1 in rice. Also automotive, so die casting of let's say whole engine blocks or of body parts, for example. But we're also in lithium-ion battery production. And on top of that, 2/3 of the world's wheat flour is made on Bühler equipment, 60% of the world's chocolate. And if we've missed you the whole day, then we'll meet you at the bar, because the raw material of beer, which is barley malt, I believe 75 or 80% actually are made on Bühler equipment as well. So that gives us a massive global scale and obviously also responsibility. And I was mentioning this earlier already. So with every small improvement we can make, also of course using data, we can actually have massive positive global impact. And we have set really ambitious targets for our sustainable value chains. And of course, Bühler processes are an important part in there. And this is of course also where it links into maintenance, because obviously good maintenance practices, they help achieve or let's say to become more sustainable. So it starts with more consistent quality, reduced losses and rework. You will have an increased lifetime of equipment. You could also say less service-related traveling that you have. You can lower specific energy consumption. Food and feed safety, obviously, which is critical, which is closely linked to good maintenance practices, but also operator safety. And all of this, this is make it a really important part of our sustainability strategy. So if you look at the industry needs for maintenance, and I think there it's really interesting to see that this is quite diverse. So if you just go through it, we can start with compliance, which obviously is absolutely critical for the industry to be compliant with all the legislation and regulation that there's around. Then of course it's about optimization of OEE, the overall equipment effectiveness. And on the one hand, this means yes, reduction of unplanned downtime and maximization of uptime, but it also means producing in-spec quality. So making sure there's no loss due to let's say missing quality compliance. On the other hand, and that's something which you would not see in OEE, it's about maximizing yield. So how much flour can we produce out of 1 ton of wheat, for example? It's about optimizing energy costs, but it's also about optimizing maintenance costs, and then a lot about planning security. So starting from the overall asset management to the production schedule, that also links to securing the raw material supply, and also including spare part stock that customers have, or let's say typically the industry needs here. And you already see, this sort of looks like we need a holistic solution. So the industry is not so much keen on individual point solutions. And this will also be a theme that you will see more in my presentation. So if you look at intelligent maintenance, obviously, again, many different definitions of intelligent maintenance. And one thing you'll find is this, what you see in this chart, which is around finding the optimal balance between reactive maintenance and preventive maintenance. And this is, I think, a common theme that I've seen a lot. So obviously, if you do a lot of preventive maintenance, this will increase the cost of maintenance. You will also have more downtime, more planned downtime, which leads to basically financial losses due to missing production volume. On the other hand, if you work too much on the reactive side, you actually may face unplanned downtime and also with a lot of delays on the productions and also financial losses. So really the question is where's that optimum? And this is what we're after, what we're trying to achieve, and give our customers advice on this, how they can get there. So then I was wondering, so in the industry at the moment, so what are the maintenance practices that we see? And when I asked actually a data scientist to come up with some numbers from this, or let's say find them from data sources we have, I was first of all, I was hoping for a pie chart, and then I realized, oh look, unfortunately the numbers, the percentages don't really add up to 100%, and actually, but that's an interesting insight I found. So if you look at the different types of maintenance that are actually, or that we see in let's say in the industry, you would see that there is condition monitoring. So this is quite high, and typically these are manual checks. So manual checks of equipment health, of component health. This is a lot, and then we see a lot of preventive time-based maintenance. So this is after a certain amount of time. We also see preventive running hours based, but this is much less, about only half of this. And then we also see reactive. So what it tells us is, yes, maintenance will always be a combination of those different types of maintenance, and a good strategy will actually have all of those integrated. So we were wondering, if condition monitoring, manual and preventive time-based are so important, so what can we do actually about it? And for the condition monitoring, so first of all, we can use digital tools to help to automate this condition monitoring. And for the preventive time-based, it's a lot about how can we find the optimal maintenance interval. So, and can we actually use data to give recommendations there. What we have as Bühler, as a product, a digital service that we are offering to the industry, this is actually a computerized maintenance management system, CMMS abbreviation. We call it ProPlant. And if you look here at the different features that you have in this system, you already see how diverse maintenance is in a plant. So what do we have? Of course, we can use this system for planning of maintenance, and this includes preventive maintenance, but you would also log the corrective maintenance, of course, so that you get a track record of it. And of course, you have a detailed description of all the jobs that you actually would have or would expect in such a plant, and of course a few more features as well to make it a complete offering for the market. But from this of course provides very valuable data for us, and I'll show you some examples of how we actually use this. When we look at the different types of analytics that could be used, I'm sure you're familiar with this value difficulty matrix from Gartner again. So if we move from descriptive via diagnostic over predictive to prescriptive, so having the hindsight, the insight, and the foresight. So I will show you examples of the descriptive, and then we move a little bit towards diagnostic, and then finally from our colleagues from the die casting business, also an example of predictive analytics. So first of all, when we look at this data from the CMMS, so this maintenance management system, so we were wondering, could we actually give recommendations on the best maintenance intervals? And what you see here on the left-hand side on this chart is an overview of all the different machine types that you would find in a plant. We just call them type 1 to type 12. And on the vertical axis, you see the mean days between preventive maintenance jobs. And the red line that you see there, which is at 100%, so it's normalized to 100%, this is actually the fleet average. So this is from all the machines in the field that we see, we can get this number. And now for this plant, you see quite interestingly, if you're above this red line, you would actually do less preventive maintenance than the fleet average. If you're below, you would do more. And this, of course, is already a first indicator for how to maybe adjust the maintenance intervals. And we're currently working on algorithms to really then predict this optimal maintenance interval. Also, of course, taking into account various other factors like the size of the plant, the load that we're seeing on the machines, and so on and so forth. Now, the second example I would like to show you, and there we'll quickly try to give you a demo. This is a system which is called Replay, and now what it does, I can start this just like in a video player, or like on your digital TV or Netflix, and you can go back in time and just replay whatever has happened in the plant. This is now a plant that produces, I believe, about 10,000 tons of animal feed per month. And for the animal feed, it's really critical to have the correct formulation, so to get the correct nutritional value of the feed product. And for this, we have raw materials which are in these bins. So this is the orange bins, and they are dosed. So every time something turns green here, you see this is a dosing unit. It goes into a scale, and the scale is then weighing the product. It all goes then finally into a mixer, and it's mixed. And that gives us a lot of data, first of all, and so we can get this data with a time resolution of typically 500 milliseconds, and it gives us thousands of signals for each plant. And this, of course, is a very valuable data source again for us. And I'll go back to my presentation. And now one thing we have done with this, and again, this is a very, I would say pragmatic thing to do. We have simply looked at how well is the process running. So we are looking, for example, at the dosing accuracy that we actually see in this plant. And typically you have maybe 50, 60, 70, something like this ingredients, which would be dosed in 1 month. And what we can do now is for each ingredient, we can simply show the histogram of every single dosing step. And from this, we can immediately see whether there are any issues. Now, so if it's red, what you see here, this would be a significant case of overdosing. Orange is a little bit off, and green is okay. Now, this, of course, has direct financial impact for the feed producers, and we would like to help them. Now, the thing is, we cannot correct for this in a digital way, because there are around three to four root causes of this, why that could be. So we have put this into a service which is actually doing assessment of plants, and then also an improvement of plants. And with this, we can give our service engineers completely new experience in terms of finding really the critical spots inside a plant. So with this, they would immediately know, based on many months of operation, where there might be an issue and what they should focus on initially. So this is again a combination of data analytics based on relatively large amounts of data, but then also something that has already been around, but typically or until now done in a non-digital way, and now we digitalize this, and of course can also think about new business model, simply because now we can directly see the improvement that this service has. And finally, I would like to show you one example from die casting. So die casting is a process which is used a lot in the automotive industry, for example. So you can die cast whole engine blocks for combustion engines, or it can also be whole parts of cars, like doors, for example. And the process works like this: that you have a relatively small amount of molten metal, which you force into a die at very high pressure. And what the business has done, they have identified the main root causes of downtime. And downtime, again, it's a massive pain for the industry, because it leads to financial losses due to missing production volume. And often there's a downtime of it could be sometimes up to a day, because you quickly need to get the right spare parts. And what the business has done here, so that they have built, they've developed a service which is a Malfunction Prognostics for the key components. So these are about 4 components that they monitor. And what you see here is that's actually the view that basically a user of this service would see. So you have a timeline which with a resolution of about 1 week. And then you would see the prediction result of the algorithm. If it's green, then the downtime risk is below 5%. If it's yellow, it's between 5 to 15. If it's red, it's above 15%. The accuracy that was achieved with this model, and maybe I can say a few words about this later, how it was done. This is actually 95% with a 3-week horizon prediction. The model itself is built on the combination of physics with some other classifiers that are involved, and because of this combination with physics, so we actually know what physical quantities are behind there. This actually also makes it a quite robust algorithm. Of course, there also fleet learning is also something that is in place. So there we are also bringing data from different machines together to further optimize the performance of the algorithm. And finally, my summary would be that, I think there are various needs relating to intelligent maintenance, and they go far beyond just uptime optimization. And industry is really looking for a holistic approach to intelligent maintenance. I think I could show you that there are different data sources that can be used in different types of analytics, and I think in the combination lies a lot of value. On the other hand, really, if we want to get towards this holistic maintenance strategy, I think we also need to realize, even in the future, it will include different types of maintenance. So definitely, preventive maintenance will still be there. Reactive, unfortunately, yes, as well. And we'll add more and more predictive and then hopefully prescriptive elements. However, the human element in all of it will remain important, at least in our industry. However, currently we're only scratching the surface of data-enabled intelligent maintenance. This is clear when we look at what percentage of the data we're actually using, and we expect much more to come in the future. So with this, I would like to end my presentation. I hope you found it insightful, and of course, I'm happy to answer any questions. Thank you very much for your attention.
Okay, thank you very much. I think my video went back on, so this is the best I can do to a virtual clap. And there's just a few minutes, but Dr. Graeber, there is one question that arose, and it is written, Matthias, can you give some examples of the different business models that you implement with your customers?
Yes, certainly. Of course, first of all, I could say this is typically a service that service business model, and now which is already important for where we're coming from as a machine manufacturer. So it's not machines, it's more about the services. And for the services, You can think about, of course, also different business models, and something we are seeing more and more. This is actually moved towards what we call outcome-based services. So this is really about making an improvement in the process and measuring this, and then somehow achieve a participation model between the producer and the provider of the service.
Let me ask one very simple question. The previous when the maintenance was strictly reactive and probably time-based maintenance, was the feeling that there was too much maintenance being done, or not enough, or simply not enough at the right time?
Again, I think it's a very good question, and I think it varies across the industry, and it varies also across the region. So Bühler is global, and our customers, I think we're present in more than 140 countries, exactly 140, something like this. And of course, depending on which region you are on this planet, there are different practices around maintenance, and this is something we clearly see. And yes, we've seen both. We see reactive maintenance really to really to the maximum, I would say. And of course, we also see plants which are extremely well organized, and maybe people do even too much maintenance. And I think again, it's about targeted maintenance and making these maintenance intervals really smart.
Okay. Thank you very much. And then, to everyone listening to me, at the end of the 3 presentations, we have a discussion section. And so thank you, Dr. Graeber, very much. Very interesting talk, and for a application that I wasn't too knowledgeable of. So I found it very interesting. So thank you very much.
Thank you very much.